Hello everyone, welcome back to my YouTube channel. This is Nehati from Sri Venkateswara College of Engineering, and today I'm here with a video on the topic OSI model. And in this video, we are going to refer to an already prepared journal, and in that we'll be saying about the OSI model. So the referred journal is the OSI model overview on the 7 layers of computer networks prepared by Sumit Kumar, Sumit Dalal, and Vivek Dixit. So in this, we'll be saying about the 7 layers of the OSI model. So the OSI model was developed by the International Organization for Standardization, that is the ISO, to create a standardized framework for the network architecture. So network has a basic architecture. To create a standard format for it, the ISO developed the OSI model. It consists of 2 components, that is a 7-layer model or basic reference model. 7-layer model has these 7 layers, and the second thing is a set of specific protocols. Protocols are nothing but rules on how the network should work. So the idea of a 7-layer model was influenced by Charles Batchman of Honeywell Information Services. The model was documented in ISO 7498, outlining how network functions should be divided into layers, with each layer interacting only with the adjacent ones. So basically, each layer has a specific part to do, and these layers will just interact only with the adjacent ones. Coming to the next one, we have the introduction. So the OSI model is a framework that defines rules for how different network systems can communicate. So the communication of different network system is defined in the OSI model. It is based on layering. The communication tasks are divided into several layers, and these layers have a specific task to perform and only interact with the adjacent layers. So each layer has a specific functions and relies on the layer above or below it to provide services. The OSI model groups similar tasks into layers, keeping them small and manageable. So the 7 layers in OSI model will be same. There are 7 layers, and this first is physical layer, second the data link layer, the network layer, transport layer, session layer, presentation layer, and the application layer. In this, we'll be seeing about each layer in detail in the further slide. So the first thing is physical layer. It defines the electrical and physical details of data connection, such as cables, voltages, signal timing, and devices like hubs and network adapters. So what it's saying is that the physical layer, it defines a physical connection, how the two devices that are going to communicate are physically connected. That is done by the physical layer. So it establish and ends connections between two directly connected devices over a communication medium. It may also handle flow control to manage data transmission rates, converts digital data. Digital data has the ones and zeros into signals that can be transmitted over physical media like cables or wireless links. So this is about the physical layers. There's a sender device and a receiver device, and it in the physical layer starts a connection, that is a physical connection between the two devices. The next one is the data link layer. In data link layer, the data are called frames. So these frames is reliably sent between two directly connected devices. So the connection is already made in the physical layer. Now in data link layer, the data called frames are sent through the connection. It checks for errors and controls data using cyclic redundancy check. So cyclic redundancy check is a error control method, and this is used for controlling and checking the errors. It only handles data transmission of a single link between two systems. If the systems are not directly connected, the data goes through multiple links, and the layers above it, ensures reliable transmission across them. So if the systems are not directly connected, the above layers ensures that the transmission is done reliably. Bridges which connect different network segments work at this layer. So the bridges are nothing but they connect different network segments. These are also working at the data link layer. Next is the network layer. The third layer is the network layer. Network layer organizes data for transfer and reassembly and handles path determination and logical address. It assigns logical address to packets So here, the data is known as datagrams, and these packets to help them find their path across the network. So in network layer, they transfer the data, that is datagrams, between nodes the same network by using the destination address. So basically, it's making sure that the data is sent reliably to the correct receiver. And the network may break messages into smaller pieces, that is fragments, send them on different routes, and reassemble them at the destination. So if the message is big, it breaks them into fragments and then sends them through different routes. And but we have to make sure that they reach to the same to the actual destination. It can also handle delivery errors and report them if needed. So the next one is a transport layer, fourth one. Transport layer helps different machines to talk to each other and let users interact with it directly. The transport layer helps in the two devices to talk, communicate between each other, and let users interact with it directly. It also allows users to choose options like speed, reliability, and priority of the connection. So it actually controls the connection. It can choose what speed the what message has to be sent, the reliability, and the priority of the messages. It makes sure that data is sent reliably even if the lower layers are not. So, if the lower layers did not send the data properly, this transport layer will make sure that it is sent properly. So, addresses are keys and methods like well known address on a named server are used to match the services to address. It controls the flow of data to avoid sending more than the receiver can handle, stopping wasteful resending. So it controls the data. See, if there are many lots of messages, it will avoid the date, avoid sending more than the receiver can handle. There's a limit that the receiver can handle. So if the sender sends more messages, many will be what wasted. So this transport layer, it controls the amount of data that is sent. It manages network traffic by sending fewer packets when the network is busy. When the network is busy, it controls the traffic by sending fewer packets, or else there will be congestion in the receiver side. It handles three steps: starting, using, and ending a connection, making sure all data, all data is sent before the connection closes. The fifth layer is the session layer. Session layer manages communication called sessions between two devices on a network. It ensures only the right people can join the session and adds security to protect the session. So basically, it does the authorization part. Only the authorized people can connect to it. It allows one way or two-way communication and uses tokens to control who can act at a time. So if a session is interrupted, it can restart from the checkpoints instead of starting over. One good thing about the session layer is if at all the communication is interrupted, it can restart from the place where it got interrupted. Don't need to start over again. The session layer works with other layers and uses the SPTU to send data. It makes sure data is sent, received, and resent if needed. If at all it was interrupted, it is resent again. It is continued, so it is resent again if needed. Sixth one is the presentation layer. In presentation layer formats data so it can be understood by the application layer. It acts as translator, converting data into a common format for sending and back into the right format for receiving. So it basically formats the data so that it can be understood by the application layer. So the application layer can understand what it meant. So it converts the data into a common format, and then when receiving, it again converts it into a right format for receiving. It handles character code translation like the ASCII values. It performs data conversion like changing bit order or number formats. It provides data compression to reduce the size of transmitted data. It ensures data encryption for security like encrypted passwords. So basically, it also provides data encryption that is for security purposes. The last layer of the OSI model is the application layer. Application layer is where users directly interact with the network, turning data into websites, chats, and more. So, application layer is the closest to the user. Users can directly interact with the network with the application layer. It supports protocols like DNS, FTP, HTTP, HTTPS, SMTP, and SSH. These are some protocols from the user end which we use knowingly or unknowingly. We are using these protocols. So this layer manages file transfers, emails, and other network services. It handles user authentication, privacy, and ensures quality of service. Everything here is application specific, tailored to the needs of the users and the app. This is the function of the application layer. So what now we'll be seeing the benefits of the OSI layer. The OSI layer works with different hardware and software from various manufacturers, making it universally adaptable. So these are universally adaptable. It can be used by different various hardware and software devices. Easy troubleshooting. Each layer operates independently, which helps in quickly identifying and fixing errors. So in each layer, if we find an error, that layer will rectify the error and then go to the next layer. So in the next layer, if they find another, it will be solved immediately. So in each layer, this error checking is done, and so it is easy to get rid of errors. Then clear understanding, the model explains how network function and how new technologies can be integrated. Built-in encryption and decryption features enhance network security. The model allows adding or extending multiple network models. So these are the benefits of OSI model. Now, what we learn in this what paper or in this PPT is that this paper explains what the OSI model is and why it's used and its contributions from various researchers. The OSI model shows how data packets move over a network during communication. So we saw in each layer how the data is moved. Improvements to the OSI model have been made over time to support new technologies. Sheedle et al. Suggested adding 3 extra layers to improve network security. So they had proposed to add 3 more extra layers to improve network security. Future updates to the OSI model will likely enhance security in other areas. In case they add more layers, it will be for enhancing security purpose. So this is all about the video. If you liked and if you understood something from the video, please do like, share, and subscribe to my channel. Thank you, everyone.